So today we're going to look at completing the square, another form of factoring and solving quadratics. So to start off, let's remind ourselves that if we had x plus some number c, that constant c, and it was squared, it's the same as doing x plus c times the quantity of x plus c. And I'm going to do this using the area model just because it really lends to what we're going to do later with completing the square. So x times x, so you take the top number and the number on the side and you use those to multiply to make what is inside. So x times x is x squared. C times x would be cx. C times x is again cx. And finally, c times c would be c squared. So if we have x plus c squared, we end up with this typical formula that always comes out as x squared plus 2cx plus c squared. So let's remember that and let's keep that in mind. So we're going to start with this first example. And we have x squared plus 10x minus 24. And that's going to equal 0. So the first thing we need to do and that we need to take care of is that we only want the variables on the left-hand side. We want to get rid of everything else. We want to move it to the other side of the equal sign. So I'm going to go ahead and add 24 to both sides using the inverse operation. So once we've done that, we have x squared plus 10x equals 24. Now from this, let's think about completing the square because we're going to hopefully get to this form of x squared plus 2cx plus c squared from using our x squared plus 10x. And luckily enough, since we have a coefficient of 1 in front of x squared, we don't have to factor out a. Another example will come on that later. So we need to figure out what will this split into. So using my area model, my square as it is, as best I can, we'll use our imagination and pretend that that's a square. We know that x squared comes from being x times x. So that's a great start. We've already got our x squared taken care of. But now the 10x, if I notice from my original area model here, I have cx and cx. The two should be the exact same. So I had two cx's. So what we need to do is take our term here in front of the x variable by itself, it's degree 1, and divide by 2 and split it in half. Because we're going to have half of it in this box, which will be the 5x, and half of it being in the other diagonal box. So that will also be 5x. So we end up having x times a positive 5 and x times positive 5 again, creating the 5x's in this diagonal from the lower left to the top right, giving us the cx or the 2cx form. So finally we have to figure out what goes in this bottom right hand box. Well, using the area model we have 5 times 5, which works out because c squared, in this case we have figured out that c is 5. This will be 5 squared or 25. So to complete the square, we actually need to add 25 to both sides of our equation. Because if you look, x squared plus 10x, well, those are in the first three boxes. But that bottom right-hand box of the square, the 5 times the 5, we were missing that. And that's why it's called completing the squares. We are filling in the missing information from the square. So if we look, x stayed the same, so we still have x. We're going to break this down into its form. And since we knew that we had to take half of the 10 to get our 5, and splitting that in half, we have x plus 5 squared. And in just looking at our area model here, we see that x plus 5 times x plus 5, each one of those quantities, gives us x squared plus 10x plus 25. So we can break x squared plus 10x plus 25 back into x, the quantity of x plus 5 squared. And this equals 24 plus 25, which is 49. So now we have this quantity squared equaling 49. Well, the easiest thing that I can think of using my knowledge of inverse operations is I want to get rid of the squared. And the best way to do that is by taking the square root of both sides, just using my algebraic principles. So I'm left with x plus 5 equals square root of 49. In this case, luckily, it's very, very easy, plus or minus 7. And now we just have to subtract 5 from both sides. So x equals negative 5 plus or minus 7. So this plus or minus 7, that's key because the square root of 49 could have been positive or negative 7. So really what this says is we now have two math problems, negative 5 plus 7, negative 5 minus 7. So let's do each one of those. So x equals negative 5 plus 7 is a positive 2, and negative 5 minus 7 would be x equals negative 12.